Now that we have discussed about the chord properties connecting angle subtended by the chord at its center or at its circumference of the circle given. Now let's see some additional properties connecting the chords. This session is about the property number 2 of the chord properties connected with the circle. So this property 2 mainly refers to the perpendicular line connecting with the chord, or how they are geometrically connected to each other. So let's see how a perpendicular line drawn through a center of the circle to the chord makes some new interesting geometrical properties coming into existence out here. So here the property says that the perpendicular here is the property number 2, which says that perpendicular distance, the perpendicular from the center of the circle to the chord bisects the chord is how we understand the property. The property says the perpendicular from the center of the circle up to the chord bisects the chord. So this is one interesting property which is identified in investigating a chord through its perpendicular distance which is passing through circle. So let's see how it bisects the chord. So here I take a circle, I take a chord. So here AB is my chord connected with endpoints A and B on the circle. Now let's take the center of the circle. Here is the center of the circle. Now the property says the perpendicular from the center of the circle to the chord bisects the chord. So from center of circle I drop a perpendicular. So here I have a perpendicular, say CD, out here. So this perpendicular CD bisects the chord AB. That is exactly, it passes through the midpoint. So when I understand this, when I drop a perpendicular from the center of circle to the chord AB, the foot of the perpendicular exactly lands at the middle point between equal distances. So here we have the property which says the perpendicular when dropped from center of circle to the chord exactly lands in the middle, that is exactly bisects the chord AB, is how we understand. C is center of circle, CD is perpendicular from center of circle C to chord AB. So CD is perpendicular distance from center of circle C to chord AB, and D is foot of perpendicular. So here I have center of circle, perpendicular distance from center to the chord AB, and D is foot of perpendicular. So the property says AD must be equal to DB, or CD bisects AB, is how we understand the learning outcome connecting the perpendicular from center of circle to the chord AB. They are equal, or CD bisects AB. This is always true when a line passing through center is perpendicular to the chord AB. Bisecting property of a chord. Now that we have seen the property connecting the perpendicular line which bisects the chord, let's see if the converse of the same property holds. Today's session is about the converse of the perpendicular property. So let's investigate the converse. So my converse question comes out to be, will the perpendicular line, or will the line passing through center of circle and bisecting the chord be perpendicular to that chord, is my question out here. So the question here is, will the line passing through center of circle and bisecting the chord be perpendicular to that chord? So this is what is the center of attraction in the converse. So let's see if it makes perpendicular. This is the converse of the previous statement. Perpendicular line passing through center bisects the chord. But what if a chord passing through center and bisecting the chord, will it make the line to be perpendicular to the chord, is what is the investigation in the converse. So let's see if this holds true. Here is a circle. Now I have the center of the circle. Let me take a chord AB. So here is chord AB and here is the center of the circle. And the line passing through the center of the circle is in such a manner that if I take a line passing through the center of the circle, then such a way that it bisects the chord here. So here it cuts at D. This cuts at D. Now here, let me take the line L which passes through center. So here L is the line passing through center C L is the line passing through center C of the circle and bisecting the chord AB, that is exactly cutting the chord at midpoint D. Therefore, AD equals DB, or D is midpoint of AB. Here is the chord AB. Now, the converse says that this line must be perpendicular to the chord. So, the answer to my question is yes. If a line passes through center of circle and bisects the chord AB, then the line must be perpendicular to the chord AB, is how we understand the converse. Therefore, that implies CD or line L is perpendicular to line AB, or you can also say CD is perpendicular to AB, is how we understand the property connecting the line and the chord. Line is perpendicular to the chord is how we understand the properties connecting the circle. So converse holds. Is how we understand the converse holds true for the property connecting the perpendicular line with the chord passing through the center of circle.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.